Freeform audio file format is a Microsoft and IBM audio file format standard for storing an audio bitstream on PCs. It is an application of the resource RIFF bitstream format method for storing data in chunks, and thus is also close to the 8SVX and the AIFF format used on Amiga and Macintosh computers respectively. It is the main format used on Windows systems for raw and typically uncompressed audio. The unusual bitstream encoding is a linear pulse code modulation or LPCM format. WAV is a file extension for an audio file format created by Microsoft. The WAV file has become a standard PC audio file format for everything from system and game sounds to CD quality audio. A WAV file is an uncompressed audio file which also stores information about the file's numbers of tracks, sample rate, bit depth, and whether it is mono or stereo. Compatibility. Both WAVs and AIFFs are compatible with Windows, Macintosh, and Linux operating systems. The format takes into account some differences of the Intel CPU, such as a little endian byte order. The RIFF format acts as a wrapper for various audio holding formats. Description. Though a WAV file can contain compressed audio, the most common WAV audio format is uncompressed audio in the linear pulse code modulation or LPCM format. The LPCM is also the standard audio coding format for audio CDs, which store two-channel LPCM audio sampled at 44,100 times per second with 16 beats per sample. Since LPCM is uncompressed and retains all the samples of an audio track, professional users or audio experts may use the WAV format with LPCM audio for maximum audio quality. WAV files can also be edited and manipulated with relative pieces using software. The WAV format supports compressed audio using on Windows, the audio compression manager. Any ACM codec can be used to compress a WAV file. The user interface UI for audio compression manager may be accessed through various programs that use it, including sound recorder in some versions of Windows. Specification. The WAV file is an instance of a resource interchange file format or RIFF defined by IBM and Microsoft. Resource interchange file format or RIFF. A RIFF file is a tag file format. It has a specific container format, a chunk, that includes a 4-character tag or 4cc and the size number of bytes of the chunk. The tags specify how the data within the chunk should be interpreted, and there are several standards for CC tags. Tags consisting of all capital letters are reserved tags. The outmost chunk of a RIFF file has a RIFF form tag. The first 4 bytes of the chunk data are a 4cc that specify the form type and are followed by a sequence of subchunks. In the case of a WAV file, those 4 bytes are the 4cc weight. The remainder of the RIFF data is a sequence of chunks describing the audio information.
Okay, so the specification for RIFF files includes the definition of an info chunk. The chunk may include information such as the title of the work, the author, the creation date, and the copyright information. Although the info chunk was defined in version 1.0, the chunk was not referenced in the formal specification of a WAV file. If the chunk were present in the file, then a reader should know how to interpret it, but many readers had trouble. Some readers would abort when they encountered the chunk. Some readers would process the chunk if it were the first chunk in the RIFF form. Other readers would process it if it followed all of the expected waveform data. Consequently, The safest thing to do from an interchange standpoint was to omit the info chunk and other extensions and send a lowest common denominator file. RIFF wave. So this is the data that is included in a RIFF wave file. The definition shows a top-level RIFF RIFF form with a wave tag. This is followed by a mandatory FMT-CK format chunk that describes the format of the sample data that follows. The format chunk includes information such as the sample encoding, number of bits per channel, the number of channels, and the sample rate. The WAV specification includes some optional features. The optional fact chunk reports the number of samples for some compressed coding schemes. The Q point, or the Q command, chunk, it identifies some significant sample numbers in the wave file. The playlist chunk allows the samples to be played out of order or repeated rather than just from beginning to end. The associated data list allows labels and notes, called label and note, to be attached to the Q points. Text annotation, text, may be given for a group of samples, for example, caption information. Finally, the mandatory wave data chunk contains the actual samples in the specified format. The WAV specification allows for not only a single contiguous array of audio samples, but also discrete blocks of samples and silence that are played in order. Most WAV files use a single array of data. Specification for the sample data is confused. These productions are confused. Apparently, data list undefined and wave list defined but not referenced should be identical. Even if that problem is fixed, the productions then allow data-ck contain a recursive wave data, which implies data interpretation problems. Specification should have been something like this to avoid the perversion. So, the metadata. WAV files can be tagged with metadata in the info chunk. In addition, WAV files can embed any kind of metadata, including but not limited to extensible metadata platform or XMP, data or ID3 tags, and extra chunks. Applications may not handle this extra information or may expect to see it in a particular place. Although the RIFF specification requires that applications ignore chunks they don't recognize, some applications are confused by additional chunks. Popularity. Uncompressed WAV files are large, so file sharing of WAV files over the internet is uncommon. However, it is a commonly used file type, suitable for retaining first-generation archive files of high quality for use in a system where disk space is not a constraint. For applications such as audio editing, where the time involved in compressing and uncompressing data is a concern. More frequently, the smaller file sizes of compressed but lossy formats, such as MP3, are used to store and transfer audio. Their small file sizes allow faster internet transmission, as well as lower consumption of space on memory media. There are also lossless compression formats, such as FLAC, used by broadcasters. In spite of their large size, uncompressed WAV files are sometimes used by some radio broadcasters, especially those that have adopted a tape-less system. BBC Radio in the UK uses 48 kHz 16-bit 2-channel WAV audio as standard in their SYSIS DIRA audio editing and playout system. UK commercial radio company Global Radio uses 44.1 kHz 16-bit 2-channel WAV files in the Genesis playout system and throughout their broadcast chain. The ABC D-Card system, which was developed by the Australian broadcaster, uses 48 kHz 16-bit 2-channel wave files, which is identical to that of digital audio tape. The Digital Radio Mondial Consortium uses WAV files as an informal standard for transmitter simulation and receiver testing. So, limitations. The wave format is limited to files that are less than 4 GB because of its use of a 32-bit unsigned integer to record the file size header. Some programs limit the file size to 2 GB. Although this is equivalent to about 6.8 hours of CD quality audio at 44.1 kHz and 16-bit stereo, it's sometimes necessary to exceed this limit, especially when greater sampling rates, bit resolutions, or channel count are required. The W64 format was therefore created for use in SoundForge. The 64-bit header allows for much longer recording times. The RF64 format specified by the European Broadcasting Union has also been created to solve this problem. About non-audio data, since the sampling rate of a WAV file can vary from 1 Hz to 4.3 GHz, and the number of channels can be as high as 65,535, .wav files have also been used for non-audio data. LP Spice, for instance, can store multiple circuit trace waveforms in separate channels at any appropriate sampling rate, with a full-scale range representing plus minus 1 volt or ampere rather than the sound pressure. About audio CDs. Audio CDs do not use the WAV file format, using instead Redbook audio. The commonality is that both audio CDs and WAV files encode the audio as PCM. WAV is a file format for a computer to use that cannot be understood by most CD players directly. To record WAV files to an audio CD, the file headers must be stripped and the remaining PCM data written directly to the disk, as individual tracks with zero padding added to match the CD sector size. In order for a WAV file to be able to be burned to a CD, it should be in the 44,100 Hz, 16-bit stereo format. Yan, naman.
Itawid.